Hi, welcome back to the channel. Today we present the last video in the GSRP series. This one talks about how does it work? Why does it work? The GSRP program is a functional training program designed to realign the joints and balance out neuromuscular firing patterns. Sounds easy. It is a functional workout. Therefore, you're going to cover the same kind of things: pushing, lifting, squatting, pressing, all that kind of thing, and twisting, especially twisting is very important, and balance work. So all that is part of the GSRP program. It is developed based on the functional orthopedic assessment of the client at hand, integrated with their level of vitality, wellness, and ability. The program will meet you where you're at, and we'll go forward from there. So how does it work? Well, first we need to take a little bit of a step back. Every individual has a life history of myofascial patterns. The way that your muscles and your fascia contract is a whole body expression. So even every thought, every emotion has a whole body expression of myofascial contractions. Okay? Also, if you've had past injuries, it'll change expression of the myofascial system. If you're an athletic person and you work out heavily, you may favor certain exercises over others and therefore imbalance the myofascial contraction patterns. So with the GSRP, we look at reestablishing balance in those patterns in order to release long-term contracted tissues that will cause, over time, joint injury. All right? So fascia. So what is fascia? Fascia is a layer or a covering of thin tissue that covers every single piece of anatomy in your body. From the superficial fascia, like skin and those organs, all the way down to like muscles, into the bones, the joints. Fascia covers everything. For example, myofascia is fascia that covers the muscles. Pericardium is the fascia that covers the heart. Every nerve, every artery, and every lymph vessel has fascia covering it. If you were to take out every piece of anatomy, you would actually have a bunch of empty cavities for every single piece of anatomy that you have. The fascia is heavily innervated, and over time it can develop chronic contraction patterns that restrict the joint movement in that area, as well as neural expression, vascular motion, lymphatic drainage. When fluids get stuck in a kinked hose, you get a lot of backup. More acidic tissues because your body isn't draining that area fast enough. And then those soft tissues and everything around them, the muscles, even the organs, are more susceptible to low-grade inflammation, which over the long term can create an injury. So, traditionally, exercise specialists, the functional training world, personal trainers, things like that, have looked at the body as a system of levers. Basically, the joint, right, moves, and the muscles causes the joint to move. However, if you disregard the fascial patterns and the fascial contractures, you will probably run into some plateauing, some problems where you can't progress, or you continuously get injured, have to heal that injury, you get back to your workout, you're good for a few months, and then you get re-injured, so the chronic acute injury cycle. In the last 15, maybe 20 years, there has been a bit of a revolution in the personal training or the fitness industry. Trainers are now studying fascial patterns under the term anatomy trains. So therefore, there's a little bit more respect given to the fact that these soft tissues can completely change your movement patterns and can completely change the distribution of the forces that you're trying to exert. So therefore, you have to consider all the soft tissue, not just the muscles you're working. And they've taken a look, like there's an anterior line, there's a posterior line, there's a lateral line, there's a torsion line. So that's fantastic. That is exactly what the GSRP program started working with way back in 2000. Now, I've done a little bit of a history. In 2003, I wrote a book on it. You can go back to some of the previous videos for that. But for today, we're going to continue on why it works and how it works. Let's start by reviewing what I wrote back in the 2000s. The JPD method predominantly intends to establish alignment and balance in all the bioenergy system that make up the human being by focusing on restoring balance and alignment in the physical body. Balancing and aligning the spine and joints will facilitate the balance and alignment of all bioenergy systems. Now today, the GSRP goals are as follows. Restore the spine's natural curves and articulations. Restore axial and appendicular alignment. Balance joint articulations and release adhesions that may restrict range of motion. Balance neuromuscular recruitment patterns. Restore neural and fascial integrity and improve cardiovascular function. And now back to fascia. As far back as 1902, Andrew Stiller, the man who invented osteopathy, states in his book, "I know of no part of the body that equals the fascia as a hunting ground." Fascia is a three-dimensional contiguous web present throughout the entire human body that creates compartments, the smallest of which hold each piece of anatomy in its place, allowing it to function optimally. Moreover, it also creates greater compartments, from deep to superficial. It helps to keep the pressure high as one of its functions, to move the fluids along the passive vessels, such as lymph and venous fluids that require joint articulation and muscle contraction to move along their pathways. And of most interest to me, the horizontal diaphragms that can affect fluid communication from brain to the extremities and back. These are the diaphragms that I pay attention to when I put together a GSRP program. Fascia research has become quite prolific in the last 25 years. The Fascia Research Society states in their short definition of fascia, fascia is a sheet or any other dissectable aggregations of connective tissue that forms beneath the skin to attach, enclose, and separate muscles and other internal organs. Now, if you'd like to pause to read the more extensive definition, you will see that what I was saying earlier, that every single piece of anatomy is encased and enclosed in fascia, is now globally accepted as a fact amongst all fascia researchers. Here's a video of living fascia. I'd like to point out two things. Notice the architecture of those fibers. Very important. We'll talk about it later. Also notice the glistening. It's full of water. In fact, fascia represents about 16% of your body's total weight. It holds about 25% of your body's total water content, and it presents in two forms, loose areolar or dense and irregular. Fascia serves some important functions, most notably structural support. Remember the architecture of those fibers and the water content of the fascial tissue in the videos? This serves to support the mechanical structure as well as provide protection against compressive forces. It is also heavily involved in the inflammatory cascade, especially when it comes to tissue regeneration, repair, regrowth. And finally, it is involved in the immune response. Let's look at some of the important cellular components of fascia. First, we have mast cells. These cells are involved in the immune and inflammatory responses. Mostly in the beginning, they raise the alarm to the immune system that there's an invading virus, microbe, or even environmental toxin. Then we have fibroblasts. These are progenitor cells. They're involved in the production of proteins for the extracellular matrix, the structure and support, inflammation and tissue growth and repair, and they also help to regulate the heart function. And finally, we also have histiocytes. Histiocytes are also involved in the immune and inflammatory response, antimicrobial, antiviral. However, those cells are more involved in defense and cleanup. That is, these cells will attack viruses or bacteria, kill them, and then take out the trash, so to speak. Now let's look at some of the subcellular components of fascia that are very important. Let's look at collagen. Our bodies produce approximately 15 different types of collagen, and the harder collagens like reticular fibers are involved in cartilage and bone production and so on. So these types of collagens are involved in tensile strength, cross-linking, periodicity, scaffolding, and turbulence. In other words, they help to provide the matrix that through which the fluids move, extracellular matrix fluids, interstitial space fluids, lymphatics, and so on. Next, we have another type of collagen called elastic fibers. Like their name says, they're stretchy. They provide elasticity and flexibility to the soft tissues. They allow the tissues to return to the original shape after stretching or even compression. They're cross-linked and create a mesh, and so therefore helped the harder collagen provide mechanical support to the structure. And finally, we have glycosaminoglycans, cells that are so involved in so many different functions, I can't even begin. But there's about 4 different groups that signal in cell hydration and scaffolding, as well as many other biological processes, including regulation of cell growth and proliferation, promotion of cell adhesion, anticoagulation, and wound repair. Now you see, the human body is heavily invested in fascia. And fascia is very important to our health and our wellness, our sense of vitality. Get up and go. Move, not feel pain. Now, if you think about every piece of anatomy is covered in fascia, that means these fascial sheaths will be gliding up against each other, right? There are muscles that are wrapped around a bone, like the piriformis, for example. There are organs that rub up against hard bone, like the heart up against the rib cage. So the fascia protects every single piece of anatomy to make sure it doesn't become injured in the course of its normal function. However, if you've had accidents, bone breaks, surgeries, things that change the integrity and the structure of the fascia, then that may change the quality of the range of motion of the local tissues and the joint near that injury site. Also, since everything is covered in fascia, these fascial sheaths will be touching each other. Now, if these sheaths have been changed from past injury, repetitive strain injuries, surgeries, anything like that, or if the fascia is suffering from dehydration, there will be some sort of adhesion or loss of range of motion of the tissues in this region. Therefore, the joint in that particular region will also not have full range of motion. Muscles will not be able to express their full force and contraction patterns. And finally, the fluids will not be able to move from one fascial compartment to the next freely, and the body will lose vitality and wellness over time. Now, this information on fascia is very key to my functional orthopedic assessments. For example, if you look at the horizontal planes produced by the bottom of the head, top of the shoulders, bottom of the diaphragm, top of the pelvis, I can determine that the myofascial structures on the left side of the neck and the left side of the lumbar spine are shortened or hypertonic and need to be balanced out by those on the right side that are lengthened and hypotonic. This is one simple example. Here is the human nervous system. This is one of 4 global communication systems. Basically, a system of tubes with fluids running inside it. The other 3 systems are the vascular network, right, the arteries and the veins, and the lymphatic network. Let's take a look at what these look like when they're superimposed upon each other, and then try to visualize how the myofascial structures being shortened can impact the motion of these fluids. Now, this diagram shows central nervous system in pink and the peripheral in yellow. Let's look at the arteries and the veins overlaid that. Now you see how well they all follow each other. Now we add the lymphatics. So you see the nerves, artery, veins, and lymphatics all go together throughout the entire body. Also consider that these tubes have to pierce these horizontal diaphragms that I mentioned earlier. So you see, fascia is a very important part of the human body. You can't ignore it in a workout. So when I put a workout together, I follow the functional orthopedic assessment, and I've seen the tissues that are shortened that need to be lengthened, tissues that are long that need to be shortened. And I put together a workout to challenge those short tissues and long tissues. Why does it work? Well, it works basically because when you are doing the program, you are mindful for every single exercise what the proper joint alignment is for that specific exercise in order to maximize the benefits of that exercise. Also, what wires together fires together. A bicep curl, for instance, right? You can curl in. Now, the bicep and the tricep are on a similar loop, right? The bicep is C5 to 7, that's where it gets its innervation from through the musculocutaneous nerve, while the tricep is on C6 through 8, getting its innervation from the radial nerve. But they work together. They antagonize each other. How? When you curl, the bicep is shortening, all the fascia is shortening, and the tone is increasing. It is a concentric contraction, but at the same time, the tricep is lengthening. The tone is also increasing because it is resisting the bicep's action while providing support. And the converse is true when you uncurl. So you never have a bicep curl that doesn't include your tricep. You'll never have a tricep extension that doesn't include support from the bicep. The whole body is wired like that. How does the GSRP work? Well, as you continue your practice 2 to 3 times a week, over time, the long, weaker muscles and tissues will shorten, and they will start to pull the bones into a better alignment. And the short muscles will lengthen, allowing better mobility on that side of the body or in that area of the body, be it back, side, front, or even a torsion, right? You could be stuck like that. It's all part of the program. As these tissues become more balanced and they allow the bones to align properly, now the fluids that are in the nerves, the arteries, the veins, and the lymph vessels can flow very freely through each part of the body, through each compartment that is divided by fascia. It has no problem moving, and therefore you will improve greatly in your sense of vitality. You will get rid of chronic pain. You will avoid injuries going forward, and you will be able to restore activities that you haven't been able to do for a long time due to pain and restriction of motion. So that's how the GSRP works. Very simple, but the human body is a complex system. That's why I'm here to help you.